Hello, friends. Welcome to Coding Garden. Welcome to an unscheduled stream, but I think it's going to be a good time. So we're live over here on YouTube instead of on Twitch, but I'll be live on Twitch in about an hour. But in the meantime, we are going to attempt to solve Advent of Code. So if you haven't heard of this, this is essentially an advent calendar of coding problems. They release it every year on December 1st, and every day at midnight, I think Eastern time, a new problem is released. And typically each problem is dependent on the last. So normally I'll solve the first few. Like I don't typically solve every single one, but it is fun to at least try the first few. They do get hard, but I'm going to do my best to solve these two, and we're going to get right into it because we only have like roughly an hour before I have to go live over on Twitch. And this will be my first time seeing this and solving it, so you're going to see my real reaction to the problem itself. Let's go. And again, if you want to do this yourself, go to adventofcode.com, sign in, and then you'll be presented with this calendar. You can see that right now problems 1 and 2, or day 1 and 2, have been released because today's December 2nd. And then in 11 hours, day 3 will be released. But here we go. Day 1. Day 1, calorie counting. Santa's reindeer typically eat regular reindeer food, but they need a lot of magical energy to deliver presents on Christmas. For that, their favorite snack is a special type of star. Star fruit, that only grows deep in the jungle. Okay. The elves have brought you on their annual expedition to the grove where the fruit grows. All right. To supply enough magical energy, the expedition needs to retrieve a minimum of 50 stars by December 25th. Although the elves assure you that the grove has plenty of fruit, you decide to grab any fruit you see along the way just in case. So I believe this is all about Advent of Code itself, because every day there are 2 problems released. I forgot to mention that. Technically, it's like part 1, and then part 2 is very much related to part 1. So, yeah. No worries, Jules. Yeah, and so if anybody wants to head over to Twitch, my overlay will show messages from Twitch as well. And if you want to play the drop game, you can do that over on Twitch. And that will do this. And if it lands in the garden, you'll get your name on the stream. But that doesn't work on YouTube. You have to do it on Twitch. Can I talk about the YouTube API? Not right now. Sorry, Samit. If you ask in the Discord, open up a thread in the Discord. I can take a look at it later. Okay. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. Good luck. I guess you're not, Jules. We'll have to mod you later. Yeah, I'm still pulling the chat API for YouTube. All right, the jungle must be too overgrown and difficult to navigate in vehicles or access from the air. And default GN, thank you for that resub. They resubbed over on Twitch while I'm live on YouTube. It's crazy. It's crazy. Okay. The elves' expedition traditionally goes on foot. As your boat approaches land, the elves begin taking inventory of their supplies. One important consideration is food, in particular the number of calories each elf is carrying, which is the puzzle input. The elves take turns writing down the number of calories contained by the various meals, snacks, and rations that they've brought with them, 1 item per line. So our input's going to be 1 item per line. Each elf separates their own inventory from the previous elf's inventory by a blank line. Okay, so this would be elf 1, blank line, elf 2, blank line, elf 3. All right. For example, suppose the elves finish their items' calories and end up with the following list. Great, great, great. This list represents the calories of food carried by 5 elves. The first elf is carrying food with 1,000, 2,000, and 3,000. A total of 6,000 calories. The second elf is carrying food with 4,000. Great. I get it. You add them all together. In case the elves get hungry and need extra snacks, they need to know which elf to ask. They'd like to know how many calories are being carried by the elf carrying the most calories. In the example above, this is 24,000. Cool, 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 cool. That seems fine. So ultimately what we're going to do is we're going to iterate over the input, calculate the total for each elf, and then return the largest total that we calculated. Find the elf carrying the most calories. How many total calories is that elf carrying? Great. Okay, so let's get started. I already have a folder here in Advent of Code 2022. And I'm going to make a directory called O1. So this will be for day 1. And I create a directory because typically there are 2 things we're going to need to solve for day 1. So I want it all in the same directory. And here we go. So I'm going to create just an index.js, and I'm solving this with JavaScript. It's the language I know the most, and it's the thing I'm most proficient with. So we're going to use JavaScript. What we need is a way of reading input. And so I'm just going to create a little function here that does that. And honestly, I guess it's 2022. We should use imports. How do I do imports? Let's try to get imports working. So if I can do, I need to import fs, which is the file system module. I think I need a package.json, and I need to set the type to module. That's what I'm going to do. So I'm going to init this with a package.json. That gives me this. If I do mjs, I guess I don't need a package.json. It's okay. It's okay. I'll make this type of module like that. Okay. Well, regardless, we have ourselves a package.json. I don't think I'm going to install any dependencies. Okay, you've convinced me. Let's just delete that package.json and then rename this to mjs. So that's module.js, which should let us use import syntax. Great. And then I don't know if I can I do a named import? Yeah, let's pull in promises and then rename it to fs. So if I make this an async function, read input, and then we pass in the file name, and I say fs.readFile, pass in the file name, that is going to read the file, and I think I can tell it, yeah, we read it in as UTF-8. And then one thing we're going to want to do is split it on new lines. So if I do file.split on a new line, this will automatically do that for us. That's probably a better way to do it, isn't it, Drill? So import fs from fs/promises. It doesn't like it. We'll try it. We'll try it. And then I'm just going to have a function called solve, and we'll call that function. We'll make this an async function, and the first thing it will do, we'll say inputs, and we'll say read input, and I'm going to do example.txt. So we'll have an example text file that we're going to read in, and then we're just going to log the inputs out. I don't use Vim key bindings. No, I'm just using like default Mac and VS Code shortcuts. So this is our sample input. So I'm going to copy that, and then over here, we'll call it sample, not example, sample. And then I'll create a new file called sample. Wait, it didn't copy. Copy? Copy? Paste. There we go. I'll save this as a sample.txt. So that file exists there. We also want to make sure that we don't have a new line at the end here. Use the input params. Sure. Yeah. Good call. Why does it have the JS logo? Cause I have an extension that does that, I guess. But I'm gonna make sure that this works with the sample. I'm gonna solve it with the sample, and then we have our actual puzzle input. So this here is different for every single person. So every person that solves this gets a completely different sample input. And what that means is you can't just copy somebody else's answer. And what that also means is you technically could solve this by hand if you really wanted to. You could just go through and like add up each line. Oh, why does it have it? Oh yeah, I don't know. I see what you're saying. It's a text file, but it has a JS. I don't know. Okay, so let's see if this works. What was mentioned is that I should pass the file name into this function right here. So that way, in a second, when we're ready, we'll pass our actual input there. But what I want to see right now is when I run this, we should see all of the inputs in an array logged to the console. Let's do it. So if I do node index, it's a promise. It's a promise. That's fine. So we need to await it. Great. So we get an array that has all of the inputs. That's good. Yeah, and Vignesh is mentioning we should trim it. Yeah, I think that's just a good precaution to take in case we accidentally have like a new line at the end of this file like this. Trim would get rid of that, and we should still get the same output. Yeah, so that's a good call. And it changed the icon. It's sample.txt now. Okay, so we can read the input. Fantastic. Now we need to solve the problem, which is essentially iterate over it, add up each one. When we reach a new line, we've got the next one. So let's go. So I think we ultimately we need to keep track of the largest sum, but I kind of want to keep track of all of the sums. I have a feeling part 2 maybe will involve all of the sums, so I'm just going to have totals. So I'm going to start off with totals. This is going to be an array that will have the total for every single elf. And then I'm going to iterate over each input, and that's going to be each individual line. And then we will also have the current sum. So current sum starts off at 0. We'll read in an input. If the input is empty, the empty string, so if input is not a thing, then we'll say current sum equals 0, and we'll push the current sum into the total. So we'll say totals.push current sum. But we only want to do that if, well, no, that should be fine because the first line of text here is not empty. So we'll have some input, and so if input does exist, then we increment current sum by input. And as a precaution, we'll parse this as a number. I guess we could enhance our read input function to like automatically give us an array of numbers. Let's do that, so we don't have to worry about it later. Well, no, because then we have empty strings because it's an array that's a mix of strings and numbers. So we're just going to do this. Yeah, technically you could use a reduce, but I don't typically think in reduce. Typically I have to solve it without reduce and then try to refactor it into a reduce. So I'm just going to keep it this way because we got to move fast. We only have 30 minutes to solve part 2 and day 2. So this should be good. So what this is going to do is add the sum until we reach an empty line. If we reach an empty line, we push that sum in and we reset. One thing we'll have to do is like once we reach the end of the file, this last sum would not have been pushed in. So we'll push that sum in after the for each like that. Now, to get the largest one, we can just log math dot, and actually we won't log it. We'll make it like this. So we'll log math.max with all of the totals. So if we look at the example input, the number we should see logged is 24,000. So let's log the result like this. So now when I run it, 24,000. Great. It works for the sample input. Let's try it on the real input and see if we can get it first try. So let's do new file. We'll just call this input.txt. We'll save that there. You see it does have a new line. I'm just going to remove the new line because I know that it shouldn't be there. Can we do top level await? I guess we can. Yeah. It's 2022. It's 2022. We can do top level await. Okay, so great. It still works. Now we change this to input and we get it on the first try. So 67016 is the answer that it gave me. So I will try it. And if I did nothing wrong, we'll get it right. Yes, first try. That's the right answer. I got 1 gold star. All right, part 2. By the time you calculate the answer to the elves question, they've already realized that the elf carrying the most calories of food might eventually run out of snacks. To avoid this unacceptable situation, the elves would instead like to know the total calories carried by the top 3 elves carrying the most calories. That way, if one of those elves runs out of snacks, they still have 2 backups. In the above example, the top 3 elves are the 4th elf, the 3rd elf, and the 5th elf. The sum of the calories carried by these 3 elves is 45,000. So find the top 3 elves. How many calories are they carrying in total? So that sounds fine. So we're going to switch back to the sample input. And I guess I should call this like solve part 1. I could reuse this. Basically what I'm thinking is now that we already are keeping track of all the totals, we can sort it and then add the top 3, right? So yeah. Yeah, I mean, you're totally right, Fraser. Like, for a simple problem like this, I don't have to use async await. I really don't. Because it's okay if it's blocking to read the file in, but it's 2022. It's 2022. We use async await. All right, here's what I'm going to do. I'm going to rename this function to get totals. And this will literally just return totals. And to get this, so that gets the totals given some inputs. And then I'll have a function, part1, that takes in the file name and then does this, and then it gets the totals from get totals with the inputs, like that. And then this returns, return math.max with all of the totals, like this, yeah. Yeah, Fraser, and again, like I'm kind of just being silly. Like, yeah, you don't need it because these are just like one-off examples, but it is fun to get used to. Okay, so that's part 1. Let's make sure that part 1 still works on our sample. Like this, it doesn't. Solve is not defined. Great, because we renamed it. So we'll call this solve part 1. Okay, we get the same answer. Great, we've reached feature parity. Now I want a solve part 2, because part 2 does the first thing of getting all the totals, and yeah, so this will be result 1, and then we'll have result 2 will be solve part 2. I guess we could technically reuse this as well. So we have the file name, we put that there, we pass the file name in here. Like that. What's up, BTRSL? Welcome to the YouTube. Welcome to the YouTube side. Okay, so now we need solve part 2, but we have the totals. But like I mentioned, it should be pretty easy. We just sort the totals, and they're all numbers. So we can just do, is it A minus B to get them from least to greatest? Let's see. Let's just log the totals after sorting. So yeah, this is going to be least to greatest. So in this case, we just need to take the last 3. So sort them, grab the last 3, pop. Pop will get the last one, and then the last one, and then the last one, and then we want to sum this up. So the total, singular, is going to be this, and then we sum it. Reduce it, we get the sum. We get each individual value. We just want sum plus value. Cool, so that's the total, and then we return the total. Let's see what we get. 45,000, and there the answer was 45,000 for the example. So it looks like our code is working for the sample input. Let's try it for the regular input. Here we go. This is our second number. Let's try it. This will be the first try for the second one. Maybe. Yeah, we did it. Great. This feels good. This is like I know what I'm doing. All right, so we did day 1. Let's move on to day 2. We have roughly 20 minutes to do this one, so I kind of need to rush, but I am missing a lot of chats. I'm sorry about that. Why don't I increment the last element instead of using current sum? Because I'm just stream of consciousness coding. There's a lot of ways to solve it. Can we use array.reduce here? Yeah, so technically this could have been refactored to a reduce, and if I wasn't going as fast as possible, I could write this as a reduce. Ultimately, you know something is reducible if you're basically taking an array of input and turning it into a single value. So in this case, we're reducing the inputs into an array of totals. And technically, it's a single value array, even though it has multiple values inside of it. But we're reducing one array to another array. So yeah, we could rewrite that. Yeah, we're on YouTube. What's up, Ryan? And what's up, Shark Turnip? Thanks for being here. Does the built-in sort just work? I don't know if it would. Yeah. Mod you? Okay, thanks for confirming. I was like, how do I know it's you? Thanks for confirming. Moderator. There you go. All right. Is your buddy live? It's a live streaming business called Stream of Consciousness. Okay. Now we're on to part 2. Let's see if I can solve this in 20 minutes. Here we go. Can you confirm yourself in the Twitch chat, Timon? I gotta move. What's up, Acid Spark? All the mods are coming over to YouTube. I got a code though. Okay. Oh wait, never mind. We have 50 minutes. We have 50 minutes, not 20 minutes. I'm freaking out for no reason. Let me confirm these mods really quick, and then I'll get to coding again. The thing is, I feel like it's more entertaining if I'm like flying by the seat of my pants, because the longer I take, people lose interest. You know, what's up, Prashant? Welcome in. Okay, so Timon confirmed himself. Acid Spark, if you're able to, can you confirm yourself? Okay, Timon is now a mod. Take as long as you want. I enjoy listening to you talk through problems. Oh, thank you, Nom. I appreciate that. 5s look like 2s? I guess so. Okay, thank you, Acid Spark. This is so, like, I can't tell which one I'm clicking on. The UI, that's why I have to do this so I can make sure. All right, great. Cool, we got ourselves some mods over here on the YouTube. All right. Well, see, look, we lost 10 viewers when I stopped flying by the seat of my pants. So let's pretend like we only have 18 minutes, and then we can hang out for the last 30 minutes. Okay, here we go. The elves begin to set up camp on the beach. Okay, I gotta click this link. Okay, great. The elves begin to set up camp on the beach to decide whose tent gets to be the closest to the snack storage. A giant rock, paper, scissors tournament is already in progress. Oh, goodness. Are we going to have to solve rock, paper, scissors? Rock, paper, scissors is a game between 2 players. Each game contains many rounds. In each round, the players each simultaneously choose one of rock, paper, or scissors using a hand shape. Then a winner for that round is selected. Rock defeats scissors. Scissors defeats paper. Paper defeats rock. We know this, for the most part. If you don't know, that's how it works. If both players choose the same shape, the round instead ends in a draw. Appreciative of your help yesterday, one elf gives you an encrypted strategy guide, which is our puzzle input, that they say will be sure to help you win. The first column is what your opponent is going to play. A for rock, B for paper, C for scissors. The second column... Suddenly the elf is called away, so we have to figure out what the second column is. Okay, no, they tell us. The second column you reason must be what you should play in response. So X for rock, Y for paper, Z for scissors. Okay, so A, B, C is what the opponent's going to play. X, Y, Z is what you should play. Winning every time would be suspicious, so the responses must be carefully chosen. The winner of the whole tournament is the player with the highest score. Your total score is the sum of your scores of each round. The score for a single round is the score for the shape you selected. 1 for rock, 2 for paper, 3 for scissors. Plus the score for the outcome of the round. It's just... There's so many rules. There's so many things happening. Hopefully we can figure this out. Plus the score for the outcome of the round. 0 if you lost, 3 if the round was a draw, and 6 if you won. Since you can't be sure if the elf is trying to help you or trick you, you should calculate the score you would get if you were to follow the strategy guide. Hopefully the example helps. And Funny Boy, thank you for that Prime resub. Appreciate you. Okay, yeah, we'll try to use... I mean, we're in JavaScript. We don't have enums, but we can create object like enums. This strategy guide predicts and recommends the following. In the first round, your opponent will choose rock, and you should choose paper. This ends in a win for you with a score of 8. 2 because you chose paper, and 6 because you won. In the second round, your opponent will choose paper, and you will choose rock. This ends in a loss for you with a score of... Oh, okay, so they've already... I was like, do we have to figure out if we should win or lose? They've already figured that out for us. They've already figured it out. The third round is a draw with both players choosing scissors, giving you a score of 6. In this example, if you were to follow the strategy guide, you would get a total score of 15. Great. What would your total score be if everything goes exactly according to your strategy guide? Okay, that was a whole lot of words to basically say rock, paper, scissors, calculate it, calculate who wins, calculate the points. All right, let's do this. Now, this read input seems really useful, so let's extract it out into like a utils folder. So right now we have the O1. Let's make a directory called utils, and then let's move O1. No, let's copy O1/index into utils. And then here, I should be able to import read input. So I'll say import read input from, let's go up into utils index, like this. And I guess we'll make it a named export. So we're basically going to grab this function and move it into utils. So if I open up the code here, basically this only has read input, and we will export that named function. So export read input. So now we can use this in other solutions. If you miss what happened there, I realize I'm moving really fast, but what had happened was we now have this file called utils that exports read input, and then we have O1, which is day one, that imports that function. And I guess we don't need promises in here anymore. So that's awesome. So now that we have that, we can create a day two, and we don't have to copy the code. So I'm going to copy the O1 directory into O2, and then we'll just remove some stuff and refactor. So if I go in O2, let's clean it up. There's an animation on the like button. That's interesting. Okay, let's clear out our sample input and give it this, which is not much to work with. Usually when the sample input is smaller, I make mistakes because I can't think through all of the possible situations, but we'll do our best. And then this is our puzzle input. So this is going to go into input.text, like that. Okay, over here, we'll have a solve part one. We'll have a solve part two. And now we'll work with sample.text. And for now, we don't have a part two, so we'll just comment that out. So right now, we read the input, and then we need to figure out what to do. So this is just like our boilerplate that reads the input for part one, and now code goes here. So let's think back to how we're going to solve this. Basically, we need to look at it line by line, and for each line, we need to calculate if we won or if we lost. So let's do it. So we'll say, I think I'm going to do a similar thing. So I'm going to create an array of the points for each round. So we'll say like points equals, what did they call this? The strategy guide? We'll just say get points with the inputs. And so get points is going to look at each line in the file, which is a space separated thing, and we need to determine if we won or if we lost. I think the other thing we could do is we could map this from just an array of strings to an array of like rock and paper, because that might be no, we'll just do it in line. So points is going to be an array, and then for every line in that input, we need to calculate how many points we got for that round. So again, I could do this with a reduce, but I'm just going to do it with a for each. So for each input, we need to parse it and calculate it. So to parse it, we can split it on the space, and that's going to give us what'll that give us? Your opponent will choose A, and you should choose Y. So this will be opponent and U. Opponent and U. So when we split it on space, the left-hand side is what the opponent chose, the right-hand side is what you should choose. Now we need to see, did we win or did we lose? So we just really need like a get result with opponent and U. So we'll pass those in, opponent and U, and then we'll push the result into the points, I guess. So how do we get the result? First we need to map A, B, and C to rock, paper, and scissors. So let's just create a opponent map. And like technically we could do it with an object, right? We could say when they choose A, that is rock. And we don't even need quotes on this because these are properties in an object. When they choose B, paper. When they choose C, that's scissors. So paper, and then C is scissors. Did I spell that right? And so now we could say opponent choice is opponent map at opponent. So what if they chose? So if they chose A, this will give us rock. If they chose B, this will give us paper. If they chose C, this will give us scissors. This is fine, but technically we could do this with an actual map, because there is a data structure in JavaScript called a map that actually works perfectly for this kind of situation. And then what we can do is you actually have to pass in an array of arrays. So an array of keys and values. So if I do this, like that and that and that, that. Cool. Now opponent map is an actual map, and we can actually just say opponent map.get with opponent like that. So this is probably the better way to do it, because you run into some potential issues if you're using an object as a map here. Yeah, I think yeah, that makes sense, Drills, but yeah, that makes sense. But let's do the same thing for the UMap. Variable names are fun. And then this is, oh, and then this is going to break because these are not valid variables. These all need to be strings. Yeah, and then this is going to be X, Y, and Z. And so then we have the U choice, which is the umap.get with U, like that. Just use one map. Yeah, why not? Why not? You don't have to say duh, though. That's really mean, Sonny. You could just say, hey, have you thought about just using one map instead of two maps? Because they actually don't overlap. And we'll call this the choice map. Like this. Cool. Now we have taken the input with A's and B's. Oh, no, not that. The sample here. The A, Y, B, X, C, Z. So we've taken that example input and we've mapped it to what they actually should be. And then we can have a bunch of if-else statements that calculates the score. Yeah, don't say duh, Sonny. Think of it as like a code review, right? Do you say duh when you're when you're reviewing people's code? I guess you might, but here's me telling you that you shouldn't. Be nice about it. Like, again, like you see me, this is stream of consciousness. I'm just coding as it comes to my mind. People do not write well refactored code on the first try. Like you have to get it out there to realize the better way to write it, right? Right? Okay. Let me make sure I did this right. Where does it tell me what is what? Your opponent will choose rock, A. Your opponent will choose paper, B. Scissors, yeah, so rock, paper, scissors is A, B, C, and no, Y, X, Z. I got that wrong. So this would be Y, X, Z. So Y is, no, Y is paper. We got to make sure we get this map right. Y is paper. Rock is X. So I did get that right. X, Y, and then Z is scissors. Okay. Shows it further up. Thank you. Yeah, I wanted to make sure. So X for rock, Y for paper, Z for scissors. And then A for rock, B for paper, C for scissors. Okay, we got that right. Then what are the points here? For a single round, the score is for the shape you selected. So honestly, if we don't even need to do rock, paper, scissors, really, right? We just need to map it to the points. Maybe not. I kind of just want to write out the logic for rock, paper, scissors now. Yeah, that's where my mind is at now. Acid Spark is like, okay, if we just put the point values in, does that work? Because rock loses to paper. Let's see. Oh yeah, I guess we can get the point scores now. The score for a single round. Makes it cleaner to have. I guess that's true. Like if you'd put like 0, 1, 2, 3 or whatever, then it can be really hard to determine what those even are. So let's actually do a point map. So this is going to be basically the opposite here. So we're going to be mapping rock, paper, scissors to their given point value. That's what we'll do. Well, thank you, Coffee Nomad. Okay. Where are the point values? Do they lay it out? Why is it so hard for me to find this stuff? Okay, 1 for rock, 2 for paper, 3 for scissors. 1 for rock, 2 for paper, 3 for scissors. And then we don't have to type it twice. We just have to type it once. What's up, Shaman? 1 loses to 2, 2 to 3, and 3 to 1. That's the tricky part. 3 losing to 1. I don't know how it. I mean, I guess like we could code that in, but that's why I want to code to rock, paper, scissors, and then we'll just map it to the actual points. Okay. We have created the map. We've got the choices. Now we need to see who wins. So if opponent choice is rock and you choice, wait. We can do it with modulus? I'm not that fancy. Okay, so 0 if you lost, 3 if it was a draw, and 6 if you won. Wait. Oh, so it's your choice plus the outcome. Okay. I have to stop looking at chat. I'm getting really self-conscious about my solution because I'm about to write some really verbose code here. But you know what? That's how I think. So that's how I'm going to solve it. So if the two choices are the same, let's solve that. Let's solve the draw case first. Go ahead. Okay, so this is if it's a draw. So if the choices are the same, we have a draw. How do we calculate the score? 3 if the round was a draw. So we'll do 3 plus your choice point. So if I do point map get you choice, that will give us how many points we get for what we chose, right? If the round was a draw, plus your score. Okay. We handled the case of a draw. The case of I guess we wouldn't have to do that. So I really just want to code out a bunch of if-else statements. And you're right, I don't need else if we return. So, and then also, I'll just put this in a variable because we're going to use it multiple times. So this is going to be the u points. So point map get with your choice. So 3 plus the u point. Okay, so if the opponent choice was rock and the u choice was... okay, so first of all, let's just handle if the opponent chose rock. It's going to be inside here. So if the opponent chose rock, and if you chose paper, then you win. So we're going to return the number of winning points plus the number of points for what you chose. And otherwise, if you chose scissors, then you lost. And so we're going to return just the points because you get 0 for losing. Right? Right? So if statements for if you win and then return and loss. Again, I have to just do my best here. So 0 if you lost, 3 if it was a draw, and 6 if you won. So if the opponent chose rock, the only way to win is if you choose paper. And if you chose scissors, you lost, so you get 0. Okay. If the opponent choice was paper, we'll have some similar if statements here. And then if you chose scissors, you win. Great. But if you chose rock and they chose paper, you lose. Great. And then finally, if the opponent chose scissors and then you chose rock, you win. But if you chose paper, you lose. Right. Okay, so you see how ugly this is? Now at this point, I would go through and refactor it, but I'm not going to refactor it. We're just going to solve it like this. Because this is how my mind thinks, right? Like if the opponent chose rock and I chose paper, I win. If the opponent chose rock and the opponent and I chose scissors, I lose. Okay? Okay? Okay. If I create a battle point var, you just have to handle win and add battle point. Oh, true. True. Okay, so we could say like win. We're going to imagine that we did not win. So we can just say win true. Win false. That actually makes it a whole lot easier. So now we only have to account for the win cases. But honestly, before I do this refactor, I'm just going to make sure my code works. Let me just make sure my code works, and then that will simplify it greatly, greatly. Okay, but let's make sure my code works. So what did we need to do? We calculated all the scores. Total score if everything goes exactly to the strategy guide. So now that we've calculated the points for every single round, we just need to reduce it into the total points. So we have the sum and the value, and we just want sum plus value. So we'll return total points. So now, we need to actually return points here. What's up, Finder the Icewing? Great. 15, is that the right answer? 15 is the right answer. Okay, let's do a refactor because now that I've had a chance to think about it and now that Drills has told me what to do here, we can just have, we'll call this game point, and that starts off as 0. And so if we win, then game point equals 6. Like this. So the other winning situation is, so we can do an OR here. So if we can have a bunch of things. So if the opponent chose rock and you chose paper, you win. If the opponent chose paper and you chose scissors, you win. You win. Or if the opponent chose, so that gets rid of that if statement. Great. If the opponent chose scissors and you chose rock, you win. And then that if statement goes away. And now we can just return game point plus U point. Look at that. That looks pretty good. Looks pretty good. Very professional code. I don't know. Let's see. Let's make sure we get the same answer. Cool. We got 15. Whew. Okay, so now let's actually try it on the other input. And Murdoch, thank you for becoming a member. That's crazy. You didn't have to do that. Thank you. I appreciate that. Okay. Let's run it on the actual input and make sure we get... Well, not make sure. We'll run it on the actual input, see what answer we get. Let's see. 15691. Are we going to get it on the first try? Let's see. Whew, this is a rare occasion. We haven't gotten one wrong yet. All right, let's go to part 2. All right. The elf finishes helping with the tent and sneaks back over to you. Anyway, the second column says how the round needs to end. X means you need to lose. Y means you need to end the round in a draw. And Z means you need to win. Well, that's easier. Why is part 2 easier? So, all right, let's go back to the sample input. And then we'll do it in a similar way. So this is the business logic here. X means you lose, Y means you win, and otherwise it ends in a draw. I'm going to rename this to get points part 1. No, here we're going to get fancy with it. So get points is going to actually pass in get result. And then that gets called right there. So in part 1, we're going to pass in get result, but we're going to rename it to get result part 1. Because this is the one thing that's going to change, is this. So instead of doing the actual like rock, paper, scissors, all that good stuff, get result part 2 is going to be a much simpler function. So we have a function, get result part 2, that takes in... it'll probably be something like this. Let's figure it out. Why is this easier? Oh no, it's definitely easier, right? Right? Okay. X means you need to lose, Y means you need to end the round in a draw, and Z means you need to win. Total score is still calculated the same way, but now you need to figure out what shape to choose so the round ends as indicated. Ah, okay, so that's the tricky part, but not that tricky. Here we have X means you need to lose. Y means you need to end the round in a draw, and Z means you need to win. Okay, so this is going to give us the opponent choice, right? Because the U choice now needs to be calculated. The U choice is not simply looking... Well, I mean, I guess it could be in a map, because we could let's create a part 2 map. Part 2 map. Or I guess we could create a lose map. So given that the opponent chooses... so if the opponent chooses rock, what do we have to choose to lose against that? So if they choose rock, we need to choose scissors to lose. If they choose paper, we need to choose rock to lose. And if they choose scissors, we need to choose paper to lose. Is that it? Is that all this? Is that everything? Is that all the situations? Because you can't... Yeah, so if they chose rock and then you chose paper, you win. If they chose rock and you chose rock, I guess it's a draw. Okay. Okay. Yeah, okay. Choice.win and choice.lose? But yeah, this is everything. Okay. And then we'll also create a win map. So if they chose rock, we need to choose paper to win. If they chose paper, we need to choose scissors to win. And if they chose scissors, we need to choose rock to win. All right, so we've got our lose map, we've got our win map, and then draw just means it's the same thing. So, We also, I guess we could create a little functor, a little thing that takes in the what. Okay, so let me get my mind straight here. So X means you need to lose. So in this case, we'll create another map to get the the function. So we'll call this the so I'll come up with the name after we create it. So basically what this is going to be, it's going to be a map of functions. So this is going to be, it's going to have a function for X, a function for Y, and a function for Z or Z. And if they chose X, then that means outcome map. That's a good name. Or like outcome functions. So here we go. If X means you need to lose. So in this case, we get the opponent choice, and we want to return lose map at the opponent choice. Like this. Or it's a lose map dot get with the opponent choice. It's pretty simple. I mean, I could really just have 3 if statements, but this will be cool because we can map it to that. So Y means you need to end in a draw. So if it's a draw, we just return what the opponent chose. And then this means we lose. So we have the opponent choice, and we return lose map. Wait, win map. This means we win map? Winamp. I spelled Winamp wrong. Opponent choice, like this. Let's confirm. Z means you need to win. Okay, so now that we have this nice little function, we can automatically determine what we should play given the map here. So uChoice is now outcome functions get at the opponent choice. That gives us back a function, and then we invoke that function. Wait. No. Get it at U, and then that gives us back a function, and then we invoke that function with the opponent choice. And so that gives us the U choice. And then now we can refactor this piece right here into like a get points function. uChoice? That's not correct English. No, but I was just going with what variable names I could come up with. Isn't there? Yeah, refactor. Refactor. No, not surround. I want to refactor this. Refactor. No, don't surround. Okay, regardless. So here we'll just say return get points. Is get points already a function? How did it know? So yeah, we'll say get points with uChoice. And actually, we want all of this. Get points with uChoice, opponent choice, and uChoice, like this. And so then we'll have a little function called get points with the opponent choice and the uChoice, and then we do this. Seems fine. But now we can reuse that in the part 2. Like that. Because instead of just looking it up by XYZ, you actually look up what your things should be. Oh yeah, get points does exist. Okay. Get game result is what we're going to call this. Get game result. Like that. Yeah. Okay. There's a lot of functions here. I mean, I almost can't follow it, but here we go. So now we'll pass in get results part 2. We reduce to the total points. Great. Let's see if we get the right answer for the sample input. We got 12. And it says for the sample input, we should have gotten 12. Okay, I think we've done it. And this might actually be another first try. So this is first try for every single one today. Can we do it? Let's see. Let's see. The drop game is rigged. All right. If I get this on the first try, this is the 4th problem we're doing today, you all have to do something, right? Be excited. Give me money. I don't know. Let's see. We did it. We got it right. That's 4 first tries today. Look at that. Awesome. I got 4 gold stars. Oh yeah, I this is a really old overlay, so the animated emotes don't work. Cool. With 13 minutes to spare. No, 23 minutes to spare? 13 minutes to spare. Hooray! Yeah, that's what I want to see. Oh, this was fun. We did it, everybody. Congratulations. Like I said earlier, I typically don't do every single one, but it is fun. If I can't think of anything else to do on stream, it is fun to come over here and do some of these advents of codes. I will mention we do have a leaderboard. Yeah. Here. So if you want to join the Coding Garden leaderboard, what's our leaderboard code? Yes. This is it. So use this code if you want to join our leaderboard. Also, I can see where I'm. Let's see where I'm at in the leaderboard. I'm 17th place. There's some really smart people, but also I think you get more points for being the first one to actually solve it. So definitely the more points you get, or the sooner you solve it, the higher you will be on the leaderboard. So that's the thing. But if you want to join our leaderboard, you can use that code. And then we also have an Advent of Code channel in the Discord. So if you're stuck on one, or you want to maybe share your solution to one, you can join our Discord as well. Someone making this a one-liner, you definitely could. Like, I was very verbose and I created like lots of helper functions, but this definitely isn't the optimal code here. Yeah, and I guess click that like button if you really want to. Yeah, so for those of you that are just joining, basically Advent of Code will release a new problem every day leading up to December 25th. But if you're asking like how does it actually work behind the scenes, ultimately the person that created this, do we have info about that? Eric Wassel created this, and so what they've done is that they've come up with the problem description, and then they've also solved it themselves. So using whatever backend language that they're comfortable with, probably I think it's Python, maybe it's Perl. But basically, they come up with the problem description, and then they also have to solve it yourself. So, and then there's like a user system. So, if for each user that signs in, they need a randomly generated input that they can ultimately pass through their backend code to get the result. So that way they can compare that result against your result. So, ultimately, this puzzle input that they give you is randomly generated, but with constraints, and then they run that puzzle input through their backend code to make sure that they get the same output as you, if that makes sense. Oh, what's up, Codex? Is that you? I think I see your icon. Here's what's what. Are you Codex? I don't know. Cool. We've got a few minutes. What do you all want to do for the next 10 minutes? I could eat my breakfast, I guess. Nice. Yeah, I'm not doing very good on my personal leaderboard. But I think the main issue is you have to solve it early, which is another reason why I don't necessarily like to compete on the leaderboard, because there are people, if you're on the East Coast, it's midnight. If you're where I live, I think it's 10 p.m. But they're literally waiting on the website to be the first one to solve it whenever the problem gets released. And I don't want to do that. I did that for a while. I did that, but it definitely wasn't good for me because I was like staying up all hours of the night, especially if it was like a really hard problem and I had to stay up way later to solve it. So, yeah. Did that happen? That's kind of hilarious if Theo was able to do. But what does that mean? I guess for Copilot to be able to solve it, that means that people upload their solutions to GitHub, which means the AI is able to pull in real time from GitHub repos and solutions. That's crazy. That's crazy. Play rock, paper, scissors. Actually, is there a rock, paper, scissors battle royale? The private leaderboard code isn't valid? Maybe too many people have joined. Let's see. Up to 200 users. No, we've only got 90 users. It should work. This one should work. Sorry about that. Is there a rock, paper, scissors battle royale? Does anybody know? Is there like a place that we can all play rock, paper, scissors against each other? Tell people you're gonna play rock, and then you will win. Should we do a? we could do a speed run where I build a rock, paper, scissors game in 17 minutes. I don't think I want to do that. Here, first person to click this link gets to play rock, paper, scissors against me. I think. I don't know if this is actually gonna work. Have people clicked it? What happened? It could just be broken. All right, let me find another one. If somebody hasn't created a rock, paper, scissors battle royale, that would actually be really fun. So like you're dropped onto a map with 100 other players, and when you encounter someone, you have to play rock, paper, scissors, and it's single elimination. So like last one standing wins. I guess that's really just like a rock, paper, scissors tournament. But it would be cool if I guess there was a site that like created the bracket for you. Yeah, I don't know. I guess I'll just head out. I'll let everybody know. Everybody over here on YouTube, definitely head over to twitch.tv/codinggarden. I'm going to be live there in like about 5 minutes. And we're going to be doing coding improv. So definitely be sure to check that out. I'm actually going to try a thing today where I stay live on YouTube. Why am I so orange? Oh, you know why? The light coming through the window over there. Usually it's blocked. But I'm going to stay live on YouTube, but I'm just going to show this. We're going to show this for the entire time that I'm live over on Twitch. Hopefully that'll get people to come over to to come over to Twitch while we're streaming over there. So I'm gonna head out. The stream isn't gonna go down, but again, you're just gonna see that screen. But head over to Twitch, and I'll be live there in like 5 minutes. So thanks everybody for hanging out. This has been fun, real fun. Yeah. YouTube and Twitch both have their pros and cons. But right now, all of my integrations and overlays and stuff like that are meant to work with Twitch, not YouTube. So, yeah. It's not time, and so I can stream multiple platforms. I just can't have the exact same content happening on multiple platforms. Yeah. Yeah. So ultimately, we're getting new viewers to Twitch, which is what we've always done. Like when I was cross streaming between YouTube and Twitch, we're basically just getting new people to sign up for Twitch. So, okay. I'm gonna see if this will work. I have no idea. This could crash my computer, but let's see. Let's see. I can leave the audio on? I'm not even gonna risk that. I'm just gonna I'm gonna try this. So the YouTube stream, I think, will go down for maybe a second or two, and then it's gonna come back up with just the image. So that's what we're gonna do. All right. See you later, everyone. Thank you for hanging out. Honestly, I'm pretty excited that I was able to solve these all on the first try. Definitely follow over here on YouTube. Follow on Twitch, and I'll see you next time.